Now the bit clock is a square wave oscillator that oscillates at some nominal frequency, very close to our desired bit rate, and then it also has the ability to be reset periodically whenever the beginning of a bit interval has been detected. So we will make use of many of the inputs and outputs that are available from this subVI. I'll begin by setting this up to produce only one sample, which maybe seems a little bit odd, but turns out that the internal state of the square wave oscillator is preserved from one call to the next. So a little bit later I will be placing this inside a for loop structure, so that way we can essentially evaluate whether or not we're supposed to apply that reset on each sample. Here I want to draw your attention to the fact that the nominal frequency needs to be specified as a normalized frequency. That means we would take our nominal frequency in hertz and divide that by the system sampling frequency, which is also in hertz. That ratio is the normalized frequency that we need for the square wave oscillator. It's always worth looking at the help pages for these devices because other types of oscillators will make use of frequency in hertz directly. So you just need to check each one and make sure you know what it needs. Alright, let me establish the for loop structure, and then I've also attached the restart bit interval to the reset input of that square wave oscillator. Now ultimately I need to see the output of this device as an array. And at the moment this is a 2D array that's being produced by the for loop structure. And we only need a 1D array, that is one sample on each pass through the for loop structure. And index array will do the job nicely. This accepts the array output from the square wave oscillator and produces a single scalar value. These are then accumulated with that tunnel that has auto indexing enabled, and ultimately then this produces our Boolean array indicator as an output.